All right, and with that, I think we are done with algebraic proofs. Okay, everyone. I know this was annoying, but hey, it's over. All right, bye. Glad that's done. I don't think I could last it. What's this?
You think it's over? It hasn't even begun.
What's this?
It's here.
All right, so quick note, this is part 2, meaning if you have not seen part 1, an introduction to proofs, please watch it. It will give you the properties. It'll give you a description of what proofs are, and it'll show you how to do some algebraic proofs. We are doing geometric proofs this lesson, so please make sure you do that. But now that I've told you that, let's go on and learn about some more postulates, theorems, and definitions. Our first one is the definition of complementary angles. If the measure of angle A plus the measure of angle B is 90, then angle A and B are complementary. Next, the definition of a right angle. If the measure of angle A is 90 degrees, then A is a right angle. Third, the definition of supplementary angles. If the measure of angle A plus the measure of angle B equals 180 degrees, then angle A and angle B are supplementary. And finally, the vertical angles property. Opposite angles formed by intersecting lines are congruent. These are just some of the postulates and theorems and properties that we're going to be using, but I just wanted to go over those right now. So here's our first thing. Remember, for each of these, we need to have a statement and a reason. So this is given AB equals CD. So our reason is given. And we know that by the end, we want to get to AC and BD. So AB equals CD, and we want to get to AC and BD. So for AC, we would need to add BC to the AB that's already there. And for BD, we'd have to add BC to the CD. So on both of those, we have to add BC, which, by the way, is the reflexive property. BC equals BC, and then we would just add it to both sides. That is the addition property of equality. Now, as we just said, AB plus BC is equal to AC. That's the segment addition postulate. And CD plus BC equals BD. That is also the segment addition postulate. Since AB plus BC is equal to AC, we can replace that. And since CD plus BC is equal to BD, we can also replace that side, meaning AC is equal to BD. And that's the substitution property of equality. Let's try another. So in this one, we're given that angle 2 is congruent to angle 3, and we want to prove that angle 1 is congruent to angle 4. So our first one, angle 2 is congruent to angle 3, that's given. Now, if I want to figure out 1 and 4, well, I know that 1 is congruent to 2, and 3 is congruent to 4, because 1 and 2 and 3 and 4 are sets of vertical angles. And now, since 1 is congruent to 2, we can replace it. Since 3 is congruent to 4, we can replace 3, meaning 1 is now congruent to 4. And that, just like last time, is the substitution property of equality. So now let's try another one. A, B, and C are collinear. AB equals BD, BD equals BC. We are out to prove that B is the midpoint of AC. Our first part is given. Now, in this case, I know that AB is congruent to BD, and BC is also congruent to BD, but we want them congruent to each other. Well, in this case, I actually know that they're congruent to each other, because if A equals B and B equals C, then A equals C. That's the transitive property of equality. And if those two parts are equal, then that means B has to be the midpoint because of the definition of midpoint. All right, here's this question. We are given that angle 2 is congruent to angle 1. The measure of angle 2 is equal to the measure of angle 1. We also are out to prove that PXR is equal to SXQ. So first we just start with our normal statement and reason. The first one is that the measure of angle 2 is equal to the measure of angle 1. Now here's the thing. PXR isn't just 2, it's 2 plus 3. And SXQ isn't just 1, it's 1 and 3. And so on both of those we have to add the measure of angle 3. And that's the reflexive property there, but when we add it, we end up getting the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 3. That's the addition property of equality. At that point, angle 2 plus 3 is PXR, and angle 1 plus 3 is SXQ. Those are both the angle addition postulate, and at that point we can substitute to get the measure of PXR is equal to the measure of SXQ. That's substitution property. All right, there we go. That's just some geometric proofs. Now, if you wouldn't mind, please like and subscribe. Hit that bell notification. Oh, and proofs will return.